Okay, so I found the critical numbers, and then I found the corresponding y values. So I found this 8 here. So I got that from taking the 0 and plugging it into my original function, f. Okay, so I found a min, a max, and a min. In part 6, there's nothing more to do. I've already found the coordinates of my relative extrema, local max, local mins. So I'll move on to number 7. Number 7, you find a second derivative, factor as much as possible. I can't factor that quadratic, so I have to resort to quadratic formula to find the zeros, to find out when my second derivative is 0. And I get this awful thing, which gives me 2 approximate answers, which is totally fine for graphing in this class. Okay, I take 0.5 and minus 1.5, put it on a diagram, find my concavity. Calculate the actual coordinates of the inflection points. Okay, you take your minus 0.5, you plug it into your function, work it out, 6.8. Then you take your 1.2, plug it in, get -1. Okay, next for the graph. Now, what did I do first? I would take, okay, I had a max. I plotted that point. Oops. Then I would plot my mins, got 2 mins, plot those. And then what are you doing? You're connecting your dots in a way that is sensible. Not forgetting about your inflection points, which are here and here. Okay, they're hard to graph, I know sometimes, so you just put a little labeling there. I know that as x goes to infinity, my function goes to plus infinity, and when x goes to minus infinity, I also get plus infinity. But really, you kind of just connect the dots, and then, most importantly, you take this graph you found and make sure it makes sense. Does it make sense with this diagram that I made? Does it make sense with this increase-decrease diagram? Okay. Are my intercepts there? All these things should make sense with the graph.